what's left is this trail of atoms going into space. We call this the planet's tail, and every planet has this to a certain extent. Earth even does have an exosphere, but it starts at 600 kilometers above the surface. It's really the point where space and the atmosphere meet. Now, in the case of Mercury, this exosphere is not at all stable. Atoms are continuously lost and replenished from a variety of sources. NASA has been able to confirm that craters at the North Pole of Mercury contain water ice. Mercury also has something which Mars lacks, an actual magnetosphere, or a magnetic field all around the planet. It is only about 1.1% as strong as Earth's, but it's still strong enough to deflect a lot of the solar wind around the planet. Now we're going to get to one of the things I find the most interesting about Mercury, its orbit and its rotation. Mercury has the most eccentric orbit of all the planets, with a distance from the Sun ranging from 46 million kilometers to 70 million kilometers. Now, this is something a bit hard to imagine, but bear with me. Mercury takes about 88 Earth days to complete an orbit around the Sun. It also has a 3-2 spin-orbit resonance of the planet's rotation around its axis. This means it spins 3 times around its axis for every 2 times that it orbits around the Sun. So, although it takes about 59 Earth days for Mercury to rotate on its axis once, which is what we call a sidereal day, this 3-2 orbital resonance means that if you were actually standing on Mercury, it would appear that one day, from sunrise to sunrise, or what is called a solar day, is 2 Mercurian years. Standing on Mercury, that would look something like this. You would see the sun rise relatively fast, and then as it approaches midday, it slows down and even starts going backwards before continuing on again to sunset. As you can see, that took a whole year, which means a nighttime on Mercury also takes a year. The sun starts going backwards in the sky because approximately 4 Earth days before perihelion, the speed in which Mercury travels along its orbit equals the speed in which it's rotating. At this point, the sun's apparent motion stays stationary. At perihelion itself, Mercury's orbital speed exceeds its rotational speed. So, to a person actually standing on Mercury, the sun appears to move backwards. 4 days after perihelion, the sun's normal motion resumes. You can see this even clearer from a top-down perspective of Mercury. Twice a day on one of its poles, the sun seems to pause and then continue on again. Something else to notice about Mercury's orbit is that it's inclined by 7 degrees to the plane of Earth's orbit. As a result of this, we can only see Mercury transit in front of the sun when it's directly between us on Earth and the Sun itself. And because its orbit is inclined by 7 degrees, this only happens about once every 7 Earth years. The last thing we'll discuss about the rotation of Mercury is that its axial tilt is almost 0, with the best measured value as low as 0.027 degrees. This is even smaller than that of Jupiter, which has been measured at 3.1 degrees. And finally, do you want to see Earth from Mercury? Well, here we are, just a couple of pixels across. This photo was taken from the Messenger probe several years ago.
Please subscribe and click notification bell. Also, don't forget to like, comment, and share. Thank you for watching my video.